All right, we have a problem here. A 50 centimeter thick layer of oil floats on a 120 centimeter thick layer of water. What is the pressure at the bottom of the water layer? So I'm going to draw a little sketch. Our water down here is a 120 centimeters thick layer. It kind of sounds weird, a 1.2 meter, so a big tall column of water. On top of the water, we have oil. And this is 50 centimeters thick. We want to know the pressure down here. What is the pressure down at the bottom? All right, so our pressure versus depth equation. This is valid in at any one given depth in one specific fluid. Because we are accounting for rho. Rho is the density of the fluid. D is how deep into the fluid. So we can use this equation to find the pressure P1 at the bottom of the oil layer. And then use the equation again to find P2, the pressure at the bottom of the water layer. Now again, I'm going to need density. So I'm going to go to the test notes, that table, page 3. It tells me the density of oil is 900 kilograms per cubic meter, and water is 1,000 kilograms per cubic meter. So P1. P naught is the pressure at the surface. So up here at the top, P naught is 1 atm. But we will want that in pascals in order to add it to this rho GD term. So rho, the density of the oil, is 900 kilograms per cubic meter. G, 9.8 meters per second squared. D, how deep into the fluid. So this oil layer is 50 centimeters deep, so 0.5 meters. So as a reminder, the rho GD term comes out to be in newtons per meter squared, which is a pascal. That's why I need P naught to be in pascals. So let's see. Plugging this in. I'm going to keep all these digits for now because I'm not at a final answer yet. So the pressure at the bottom of the oil layer is a bit bigger, 105,710 pascals. So that is the pressure at the bottom of the oil. To continue and find the pressure at the bottom of the water, so P2 is what I'm calling that. In our equation, P naught is the pressure at the surface. So for the water, the pressure at the water surface is P1. So instead of atmospheric pressure, I need to put P1 because that's the pressure at the top surface of the water. So this is accounting for what that oil layer, that weight, that pressure due to the oil layer is. So now we're talking about going down into the water. So the density I want here is the water density, because we're finding the pressure at the bottom of that water layer. The depth I want in meters, so 1.2 meters. Now this is what my calculator tells me, but of course I do not know the answer this accurately. So please do not give me huge significant figure numbers. Here at best we have 2 sig figs. So the 50 centimeters. So scientific notation comes in very handy now. 1.2 times 10 to the 3, 4, 5 pascals would be our answer. We could technically put it in ETM if we wanted, since this problem doesn't specifically ask for specific units. But leaving it in pascals is also fine. Our pressure, 1.2 times 10 to the 5th pascals.